Hey there, welcome back to Matt's Math and More. Today we're going to work on generating and graphing ordered pairs. If you're following with math expressions, it goes along with lesson 7-6. If you're not following math expressions, it is just plain old generating and plotting ordered pair. Not too hard. It should go nice and smooth. Not as bad as being attacked by a killer snail or anything like that. Could be worse. All right, let's check out this word problem here. Let's suppose there was a snail who could travel 20 inches a minute. Oh, that's a fast one. Fast snail. So time and distance would be how I'm going to set this up. And we'll know that time is going to be our x-axis, and distance will be our y-axis when we set up a graph in a little bit. And I know at 0 minutes he traveled 0 inches. And they told us 20 inches a minute. So at 1 minute, he traveled 20 inches. Now, set it up. You could probably just see what the pattern's going to be, but don't get in a bad habit of just guessing and hoping you're right about these patterns. Always go back to your fraction, your unit fraction in this case. What's 1 times 2? 1 times what is 2? So it's times 2. So 20 times 2 is 40. So at 2 minutes, they went 40 inches. 1 times 3. 20 times 3, we got 60 inches. 1 times 4, 20 times 4. We have 80 inches. Now, why is it important to go back there? Let's pretend in the future, when you get into higher level math, you got a pattern that it's the same 1 and 20, but they skip. They don't go 1, 2, 3, 4, 5, 6. They went 1, 3, 5, 6. So you don't want to just go, 20, 40, 60, because it'll be incorrect. You want to know 1 times 3. Okay, this one's 60. But this one doesn't follow the pattern. It goes right to 5. So 20 times 5 is 100. And then it skips to 6 here. So 20 times 6 is 120. Don't always assume that the pattern's going to go consistently across, just like this one did. Next thing I want you to do is think about just writing your XY ordered pair. So if you go back to our ordered pair lesson, it would be like ordered pair 0, 0. Ordered pair 1, 20, XY. Ordered pair 2, 40. Ordered pair 3, 60. And ordered pair 4, 80. There we go. So for our next part, what I did was I turned our x and y into a graph. So on our x-axis, I put time, which we knew was 0, 1, 2, 3, 4. So I just went 0, 1, 2, 3, 4, 5, 6. So I went up to 7 minutes anyway. And I did distance for the y-axis. I forgot to label it, but there we go. Y-axis. And 10, 20, 30, 40, 50, 60, 70, 80, 900. I just put the inches on that side. Now, let's plot our points. We got 0, 0. That's our origin. There we go. At 1 minute, he went 20 inches, so right up. 1 and 20. At 2, he went 40. Right up. 2, 40. 3, right up. 60. And 4, 80. Then what you would do is take your ruler. Always use a ruler. Don't freehand this. Draw yourself a nice line. And actually, I'm going to extend my line a little bit. It went even further. So we know here's our points that we plotted. Here's our line. You could see the slope. You could see what the snail is traveling. And you got a nice line graph that represents this graph. Hey, let's suppose I asked you a trick question. Let's suppose I threw something in the middle here like at 3.5 minutes. Instead of doing 3, I said, what did they do at 3.5? Well, you can sort of see it on this graph. If 3 was 60 and 4 was 80, halfway between 60 and 80 would be 70. See how it just kind of went halfway? You can also see it on this graph here. If 3 was 60 and 4 was 80, well, 3.5 would be this line, and it also lands, pretty cool, right on the 70 mark. So that's 70. So you could see either way. You could even extrapolate other information like halfway points. Look, landed right on the 70 when I took a halfway marker. So graphs, graphing ordered pair and putting them together, looking at it like this, looking at it like that, very helpful when you're doing math and science. Ooh, there's no such thing as a killer snail.